So we're going to start our study of static electricity. And the first thing that we're going to look at is just the fundamentals of electric charge and really how do things become charged and what does it mean when something has an electric charge, whether it is either positive or negative. So a fundamental charge is really the groundwork that we need to understand in order to be able to develop how things are charged or how charging is actually taking place. All right, so electric charge is going to be present whenever something has an unbalanced amount of protons and electrons. So protons are going to indicate P plus, and obviously those are positively charged. Electrons, E with a minus, right? And obviously those are going to be negatively charged. When those two things are unbalanced, then something is actually going to have a charge. And we're actually going to be able to calculate that charge using the equation Q equals NE, right? Where this E is our fundamental charge. It is the charge of a proton or an electron. If we just had a single proton or single electron, what would that charge be? So that's a plus or minus, depending upon if it's a proton or electron. 1.6 times 10 to the negative 19 coulombs. Okay? Coulombs, that is an SI unit. So that is basically what we are going to measure charge in. Okay? N is an integer. Basically, N is going to equal plus or minus, or actually 1 or 2 or 3, and so forth, depending upon the excess. This basically tells us the excess protons or electrons. Okay? And this is the charge of the object that has the unbalanced numbers of protons and electrons. Right? So we're going to do a few examples that's going to show us how we would use this idea. All right, so our first example is going to be looking at a question where it says, how many more electrons does a negative 1.0 Coulomb object have? So what we have to think about is if something has a charge, right? So if this is an object and there's some electric charge, right? And we can measure that electric charge. What we know is that there are, this object has protons and it also has electrons. However, what we know is because it has a negative charge here, that tells me it's going to have more electrons. So in terms of doing this, I should be drawing more electrons than I have as protons. Right? Now, if we go back to what we learned in chemistry, this means that this object gained electrons. Okay? It did not lose protons. Those are the two ways that something could become charged. Right? Things don't lose protons, things don't gain protons for the fact that protons are the things that make objects or make substances what they are. Right? Hydrogen is hydrogen because it has one proton. Carbon is carbon because it has 6 protons, right? So it's not the movement of protons, but it's the movement of electrons, right? So this object became negative because it gained additional electrons. So what we want to know is how many more electrons does that object have compared to the number of protons that are actually there. So we're going to use our equation, Q equals NE, okay? And what we're looking for is we're really looking for N. Right? What is the integer value? How many more electrons are there than there are protons? Right? So in doing that, N becomes Q divided by E. Q is my charge of my object, right? So it's negative 1.00 coulombs divided by the charge of an electron. Negative 1.6 times 10 to the negative 19 coulombs. Right, what we see here is my units cancel out, which is good because we just want a numerical value with no units after that. And if I plug that into my calculator, my negatives cancel out as well. And I get 6.25 times 10 to the 18 electrons. So that is how many more electrons that I have than protons. That's a substantial amount, right? That's a huge amount of electrons that I have with just a single charge of 1 coulomb, right? 1 coulomb is actually a huge amount of charge, and you'll see that as we work through problems. Usually we're talking through nanocoulombs or picocoulombs or millicoulombs or microcoulombs, right? So this is times 10 to the negative 3 times 10 to the negative 6 times 10 to the negative 9 times 10 to the negative 12. So usually the charges that objects are going to contain are really, really small, right? But if something has 1 coulomb of charge, it is a substantial, it's millions of additional electrons than it has in protons, okay? So we can build on this example, and the second part is to say if the number of protons is equal to 6.25 times 10 to the 18, how many total electrons, right? So how many total electrons would we actually have if this is how many protons that we actually have, right? So again, we're a large amount, right? And so to think about this, N is basically equal to the number of electrons minus the number of protons, okay? So what we can see is if I'm trying to figure out how many total electrons that I have, I can simply add my number of protons over, and I get N plus my number of protons equals my total number of electrons, right? So N is here, 6.25. So what we get 6.25 times 10 to the 18 plus 6.25 times 10 to the 18. And what's that going to give me? Obviously, that's just like 6.25 times 2. So that's going to give me 12.5 times 10 to the 18 total electrons, right? So just understand, this here is my total electrons, whereas here is my extra electrons, okay? And it's the extra electrons that actually produce the charge of the object.